Hello, this is Wyland with the FPV podcast, where we talk about the FPV community and everything we do with our radio-controlled machines. Before we get into the show, I just want to very quickly touch upon our Patreon giveaway. This is a monthly giveaway that we're going to be doing for our Patreon supporters. So we're going to be giving away a lot of great products. So if you're interested in supporting the podcast and being entered into the giveaway, please go over to fpvpodcast.com. That's fpvpodcast.com. Thank you so much for supporting the FPV podcast. Hello everyone, welcome to this week's FPV podcast. This week we have two individuals that started an FPV company. They make some very interesting products and we're glad to have them on. But before we introduce them, Elvin, what do you got today?
You were supposed to say, all hail the mighty wing pilot Elvin.
No, I'm going to kick you off now.
Oh, damn.
What did I tell you about cussing? What did I tell you about cussing?
Hello everybody. Hope you guys are enjoying your times out there with your family and your friends, and it's that time of the year on this side of the planet. And we're doing a lot of flying. We're having a lot of fun and enjoying the Northwest with all these beautiful trees to run into, and all the scraggle is gone. If you don't see it, you will know it's there.
There we go. All right, so let's go ahead and introduce our two guests who are sharing a line. They are the owners of BrainFPV. Martin, can you please introduce yourself?
Hey guys, I'm Martin Luessi. I'm the founder, I guess, one of the founders of BrainFPV. Yeah, and that's my wife, Jenny.
Hi, I'm Jenny. I'm also a founder. We make the most advanced, superior drone electronics on the market.
There we go. Oh, the challenge. It's been laid down.
Mic drop.
All right, so I will take over from here. So why don't you two tell us about exactly how you got into FPV before you started BrainFPV? Where did this passion come from?
All right, that's a long story, but so yeah, I started flying RC. I grew up in Switzerland, so I
Really?
So I started flying
From
RC
his German accent.
like 30 years ago, probably. With my dad, we were flying like gliders, like electric gliders. Actually, the town where I grew up, there's actually like, it was like one of the first electric-only meets in the world. They had every year, so it was like this big event. And I would go there as a kid, and there was the first electric helicopters, like RC helicopters with nickel cadmium batteries, totally ridiculous, like 1 minute flight time and stuff. But yeah, so I was flying gliders as a kid, and then I kind of stopped, went to college and so on. RC is not cool if you're like a teenager.
Life.
Or back
That's
then it was.
life.
Now it's
Now it is.
but so I stopped, and at some point I did university and so on, and then I moved to the US for school. At some point, we were living in Chicago. I somehow I guess I had got one of these like toy RC helicopters, the ones that are like super cheap, like fixed pitch.
Yeah, his stepbrother got it for him for Christmas.
For Christmas,
yeah.
like one of these toys. And I was like, oh, that's pretty cool. And then I was like, I kind of Googled around. And so I found like, you can get an RC helicopter for like $1,000. Like you could get like everything you need, basically a pretty basic, like a 450 size helicopter.
Yeah.
And I was like, wow, that's crazy. Because when I was a kid, like, RC helicopters was like this thing that would cost as much as a car. It's like thousands of dollars. So I was like, oh. So I've got a T-Rex 450 and started flying that. Like, every morning I would go to like public parks in Chicago and fly it around and stuff. And that was fun. And then at some point, I guess I came like across the videos that like Raphael, like Trappy was doing like in Austria, he's flying the crazy mountains. And I started kind of figuring out how to build an FPV system, and I got some FPV video goggles. Like I got some really old school. Well, I got some video modules from like eBay and put them into ski goggles. But then I got sidetracked.
Oh, you did the ski goggle mod.
Oh my god.
Yeah.
Yes, I did that too. That was so awesome, dude.
With duct tape all over it.
That was awesome.
This was with hot glue, right? So like,
there's a lot of hot glue.
Can you imagine? Can you imagine what people's heads would look like with hot glue around now? I mean, it would have been like this 5-pound block of hot glue on their head. Oh man, I remember those days, man.
But what's funny is I recently, side note, I recently posted a Throwback Thursday, like with Martin flying with those big, like the ski goggles with the duct tape and the hot glue and everything. And so many people posted, wow, that looks so much more comfortable than
it actually kind of was.
The Fat Sharks. Wow, like actually, that's a really good idea. We should go back to that. Start over. Okay, anyway.
But so yeah, so yeah, I kind of started that, but then I got sidetracked. I was doing my PhD at that point, and it was a lot of work, so I didn't do FPV. So then we moved to Boston from Chicago, and there was like an RC heli club, and I was flying my RC heli, and then some guys there started flying quads, like the bigger, like 450 sized, or like the DJI like quads, and then I was like, oh, I should really finish this FPV stuff. So I was like, should I get a bigger RC heli or should I build an SPV quad? And I was like, oh, let's build an FPV quad. It's more nerdy. So I built my first FPV quad with like a CC3D, 450 size quad. And we started flying it there at this club. It was a bunch of us that started. It was like 2013 or so when we started that.
Really?
Yeah.
It was like
2012, 13. Yeah. Like around that time. And there was like a whole group. It was interesting, like through FPV Lab. That's like, it still exists, but I guess now these days with Facebook and so on, it's kind of, people don't use it much anymore. It's like a website, a forum. There was like a whole community in the Northeast, and they're still getting together all the time. It's
Did
really
you say good. FPV Lab?
Yeah, FPV Lab.
Yeah, that's where I'm at. Hey, if you want to know something about FPV, there's RC groups, right? Then there's RC Universe, and then there's FPV Lab. I mean, exactly. It specializes in FPV. So if you don't know something, go there, ask it.
So it was great, and so I started flying this quad with a CC3D and like no OSD, or at some point I added an OSD, like a minimum OSD, and I was like, I want something better. Mm-hmm. I want something that's like a flight controller has an OSD in it. So that's actually how it prompted me to build the first, like the original Brain flight controller. Mm-hmm. That started in 2013, like 5 years ago.
Well, you just you were super frustrated and like couldn't find anything on the market that was like.
Well, I wanted a graphical. So it was actually 5 years ago. It was a graphical OSD and an F4. So in a 36mm form factor. It was very ahead of its time. It was the first flight controller, the first 36mm flight controller with OSD, and it was graphical.
And F4. Cool. It was one of the first F4 in that form factor as well. And then people got interested. People were like, I want to buy this, and then that's kind of how the company started. So it was like a side project first, and then evolved into something more.
That's usually how it goes, right? It's a frustration that you have, and you solve the problem, and other people were like, "Hey, you know what? That's pretty cool. Can I buy that?" And it takes off. So before we actually get into BrainFPV, because you did fast forward us to current, mostly current events, Jenny, how did you not run away when he's going through all of this nerd stuff? Because it's quite obvious both of you are very smart and you actually know a lot of math, but not a lot of females actually like doing this stuff. So what was your introduction into this, and how did you actually learn to really like it and be passionate about it?
That's a really good question. I'm a nerd too, so just to like lay down that foundation. I'm a total nerd, and I don't know. I think that at first, I would go flying. I would go flying with Martin and just kind of watch him fly, and I think that I really enjoyed watching the videos, and so. And it's funny because I always make fun of Martin's flying. I was like, oh my God, you hover, but you should see me hover. I'm the best hover ever. I'm just kidding. That's all I can do. But I didn't know how hard it was at the time. So, anyways, no. But I think that for me, my background is in cognitive neuroscience, developmental cognitive neuroscience, which means I study the development of children and the brain. And
study me.
Yeah, so exactly. No, Elvin, no. So we were actually both in academia, and I just was watching Martin, build and grow this company, and I just felt like I just saw this huge opportunity to open the door to a much wider audience with FPV, and it's so, I mean, whatever, it's so STEMmy, right? So I mean, it's just like, it's so beautiful, you know, just to teach people the basics on circuitry and physics and, you know, power and frequency and, you know, so on and so forth, right? So I mean, it's everything, and I don't know, I fell in love with how I think, yeah, I think drones aren't going anywhere, and I think that even people with a limited background in electronics or, you know, coding or anything, you know, they could really get into it. And just by watching these videos, and nowadays, oh my God, I mean, these gorgeous videos of the aerial photography and, you know, of just, you know, Gab 707 and Bryce Skyberries, and TBS just came out with a crazy video, snowboarding. It was like an Audi video or something like that. And so, I mean, I just feel like there's just so much opportunity for people to get creative with FPV. And, you know, it's a great opportunity for kids and women and everything to get involved. So people just have to try it.
Right.
You know?
Right.
So,
well, that's great, you know, and we appreciate your participation, and we encourage all women to enjoy themselves in FPV. And also, you know, if you don't, then it's perfectly fine. But
I encourage everybody, not just women.
Exactly.
Everyone.
Yeah.
Kids.
Everybody.
Everyone.
You know, kids,
Yeah.
young kids. You know, I met a guy not too long ago, a couple of days ago, that his kid is in a special school, and his kid watches me fly from his window in his house. So it's like, okay, now I know about that now. So like I go and I fly by his window, you know, close up so he can see it. And that's what I'm talking about. We need to keep reaching out. You know what I mean? This hobby. Go ahead,
Sorry.
Martin.
I was gonna say, like, you should get him one of these small FPV screens, you know,
so
you can
see
tune
what
into
you're
your
seeing.
plane.
Yeah.
I think that's something that we're gonna talk about.
Oh, there we go. I like that. That's a great idea. And, you know, being all inclusive is what we say.
Right.
So let's go ahead and continue on with the story. So, Martin, once you designed your first board, obviously, the market came to you. So, like, how did BrainFPV come to be? As in, like, how did you get the name and how did you start selling?
So the name is back then, when I first started making that board, the original Brain flight controller, I was working in neuroscience as well. So I was like doing Jenny was a neuroscientist, or she is a neuroscientist, and I was doing mostly writing software to do signal processing for neuroscience.
He was developing the tools that I was using to measure brain activity.
Yeah. So basically.
I told you they're smart.
So you know, that was kind of close. I was like brain, and I don't know. I mean, you know, the flight controller is the brain of the drone, so it kind of makes sense. Brain. I mean, in hindsight, you know, there's a lot of flight controllers that are somewhat called brain. There's like for 3D headers, there's another brain, and blah blah blah. But it was kind of a cool name. And back then, it's also like these days, like if you look at the names, like everybody's like something FPV. Back then, that wasn't the case. Like 5 years ago, no one did that. So you know. So we call it BrainFPV, and we made a flight controller. So the original logo, it's actually this one. That was the original logo 5 years ago on this QC here. Yeah. It's actually just a brain.
It's his brain.
And it's actually generated from so that was kind of cool. It was generated from an MRI image from my brain
I administered.
that she had acquired. I was her subject. So that was, you know, it's my brain, so that's kind of nice.
I told you we're nerdy. I'm sorry.
And when she gets angry, she goes over and stabs at it.
Wait, look, honey, look what I made. I made a picture of your brain.
Isn't that romantic?
Cool. You can have like a 3D model. You can actually even print it. You can like do a 3D construction of your brain and then like print it with your 3D printer. It's actually kind of neat.
Look, my section is bigger than yours.
All right.
Actually, yeah.
No.
So that's how
that's a story for another time.
That's how the name came to be. And then was this the other question?
No, I want to hear the story. Hold on, Jenny. You can't cop out on me now. I want to hear the story.
What story?
No, what the other question was that?
He's like, no, we're not.
Well, I guess, you know, I started selling these flight controllers. Well, it was actually right around that time. We got married too, and then I finally got the green card, so I could actually legally start a company. Because before I wasn't really allowed to do that, I think. So then I once I was allowed to start a company in the US, I started a company because if you sell stuff and stuff, you want to do it proper. So you start like an LLC or something like that. So I started a company and started selling them, and the first 1 or 2 years it was just a side project, and I was having a full-time job, and it wasn't making a lot of money. It was just funding my FPV addiction. All the money, basically a zero-sum game, more or less.
He was faculty at Harvard. Sorry.
There you go. Holy cow.
Yeah, but so then at some point I decided not to stay. I didn't want to stay in academia because of various reasons.
His long-lasting addiction.
Well,
to FPV.
no.
FPV.
I mean, I was looking for other opportunities, and then at some point, someone approached me, and they were looking for someone to do consulting, like for a drone project. And I was able to talk them into giving me like a 50% of my time job. So that was quite ideal because I was able to like work 50%, work for them and 50% for BrainFPV. And I mean, in addition to want to get out of academia, it was also like I was writing code all day. I didn't really do anything tangible, like you go home in the evening, you wrote like thousands of lines of code, or not thousands, you write a lot of code, you don't really see what you did. And so that's what I really like about drones too, or FPV, is like you build something, you make a physical product, and I kind of prefer that. I really like making I've been making circuit boards for over 20 years, so I really like. It's kind of a weird thing to like lay out the circuit board and do the traces and stuff.
He has dreams. He has dreams about circuit board.
So
Martin,
I really got back into it.
Martin, I can say this. I've done a couple parts placements on a couple of chips.
Yeah.
The 486 DX2 chip. Do you remember that chip?
Yeah.
I signed off on that, so I actually got to watch all the pinouts and all of that, the placement and chip placement for that, and it was really, really cool to watch how they compress everything into that chip size and then layer on top of layer and clearing vias and all of that, man. It's just amazing how we do those things and make the things that we use every day today now.
Yeah. I mean, it's crazy, like, right? It's like, like 30 years ago or so, like it was, electronics were kind of understandable. You would look at the product and, the few chips inside. But these days it's like basically black magic, right? It's like your phone. There's a few black chips and, there are billions of transistors in there. And
gas permanent
it's crazy.
Transistors now,
It's amazing what we can do these days.
That is definitely true. So that's actually leading to a really good question. Like, obviously you guys did a great job with your flight controllers, but like when you started this idea of building your own flight controller, I mean, isn't that a daunting task? I mean, like, where do you even start, and how did you actually progress through it to actually have your own board?
Well, back then, so back then there was like, I originally started, like, there was the Open Pilot project. And they actually, like, their hardware was mostly like open hardware, so the schematics and everything were available online, and so it was quite approachable, and I think it still is. If somebody's dedicated and wants to make their own flight controller, a basic like an F4 flight controller it's not out of reach of someone who knows how to make a circuit board. Like, right. And even like you can even assemble it yourself if you have steady hands and like what you're doing. You can basically assemble your own F4 or whatever, F7 if you want. Flight controller, and then you have your own. So it's a pretty cool thing to do. So yeah, it was kind of step by step. Like I hadn't made circuit boards in a while back then. I did some other. I went to school and stuff, but yeah, it's not terribly difficult.
Now,
whoa,
reverse. Oh my god.
Well, I said a basic flight controller.
Okay. Whoa.
Okay, go.
Oh my god. Sorry. So can we retract that statement? So for Martin, it wasn't that difficult. Martin has a PhD in electrical engineering and computer science from Northwestern.
I agree with Jenny.
So to Martin, it wasn't that difficult. And I think that everybody has to really, really, really
It's
think
all
about
relative.
that. No, but I think that a lot of people, we're seeing a lot of flight controllers come to the market every day, right? And they're shit. Sorry. Oh, crap.
You
That's
can say
okay.
that. You can say that.
The quality is, the designs are not great. The quality is not great. They're mass produced, poorly documented. And I think that it's because of maybe, the lack of experience and the lack of education and the lack of theory, right? So you need to have
cutting corners.
Well, and cutting corners.
I
Right.
agree
So
on
there's
the
like all of the above, and I feel like right now, so it's not often that you actually see an electronic device that's built for this hobby, or now I guess we can call it an industry or a sport, that is well designed by somebody who actually maybe knows what they're doing. Wow, that was a big claim. That was a bigger claim than what you just said. I'm just digging myself in a deeper hole here. All right.
Well, let's try to keep her from digging a deeper hole.
No, actually, I want to.
Wait.
Go.
I want to say something. One of the things is that people don't realize that it's easier to build something outside of the U.S. than it is in the U.S. We have laws. And the bigger the company, the more laws we have to deal with. There's corporate entities and, lawyers you got to pay to cover somebody's behind and this, that, and the other to keep from infringing on this person and that person's stuff, and then, lo and behold, let you decide that you're going to do something on the day somebody else decides. And then all of a sudden it became you copied something, even though you're on two different sides of the planet and you thought of it almost at the same time. And really, if you really think about it, many things that are produced today was actually thought of by two people on two different points of the planet, and one was poorly developed and one was properly developed. And that's usually what happens, right? That's usually what happens. That's how we end up with a product that is a substantial product for the day. It's one guy like me. I go, oh, you know what? I got an idea, and I fail to get it done. And then some other guy goes, hey, I got an idea, and he gets it done. So I think a lot of the flight controllers and electronics today are produced to go out the door as fast as possible. It's not about getting a product to the market and building on that product. It's about how many units we can deliver quickly and then develop another product later.
Exactly.
Because nobody, that's one of the things I was arguing about with somebody the other day is all these, in the last 4 years, we've had several products that came out. The manufacturer knew they were crap. Came out and said there was I'm going to name this one product, Foxeer, the camera, the Aero 1, right? Everybody bought that camera. Then Foxeer says, you know what? We made a mistake. And in the camera, if you set your name or the time or you move stuff around, as soon as you unplug it, you plug it back in, you got to do it again, right? And people still bought the damn camera, right?
Don't care as long as it's cheap.
They didn't take it back. They didn't give you a refund. They didn't give you a discount on nothing. You just was asked out of $39. And that's what I'm talking about. People just, bam, hit the market. Oh, we screwed up. Buy the next one. That's how we're gonna fix it.
I mean, one way you can see it, like, it's actually funny. Like, recently we had the new flight controller, and then we did batch 1 and batch 2, and then everybody was asking, so what are the changes for batch 2? And we were like, there's no changes. Like, because before batch 1, there was actually a batch 0, which was like a small batch, that we gave to our test pilots and so on, that to make sure that it actually works. Like, whereas other brands, you often see like the first batch has like
so many problems. So they're like testing it on the customers who paid for it. They paid money to be a beta tester.
Right. That's a bull.
It just blows me away. And then they have to do anyways. So, okay. So Oh, sorry.
No, I
Go ahead.
agree. And like, just to back up her statement, there's a lot of truth. If you look at the history of it, we have a lot of a lot of flight controllers where you had to do weird stuff like put rubber O-rings, and some of them didn't have to. And we know it's a problem with a flight controller, but nobody wanted to own up to it or do a recall on it because they would lose their ass out in money, which is a problem.
They didn't know how to fix it. Yeah, because they didn't know what they were doing in the first place.
Yeah, and then there were a lot of things where like chips would just fall off because things were melting because people were putting chips in wrong places. Happens all the time, right?
People are really bad at soldering.
Oh yeah.
Talk about that.
Oh, that's mean, but yes, that's very true.
No,
too.
but we designed our flight controller with that in mind because that's real. It's a real thing, and I think it's something that we need to think about because we have customers and we don't want to, we don't want them to mess things up and to burn pads off and to,
burning pads.
Hey, I was one of them, right? Everybody has to start off like that.
That's what you get when you try to use a 100-watt soldering iron to solder.
Exactly.
But that's not in there's no instructions. It's not like it says what temperature to solder. I mean, whatever, for a beginner.
Yeah,
if you have no
that has to be to do also with the, people look at the specs and it's like they want a lot of people want as many features as possible, right? And like they want 6 UARTs and like blah 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 in like a 20 by 20 millimeter form factor. But that means you have to put extremely small soldering pads extremely close together, and for a lot of people that will just be very, very difficult to solder, and then it creates a lot of problems. Like, so I think in the end we created the current generation of products with that in mind. There are features that we could have added that we didn't add just to make it easier to use.
So let's go into that. Can we go into it?
Go.
Okay. Yeah. So basically, so we've just talked about all of these issues, all of these problems, lack of innovation, integration, education. So we were like, all right, so yeah, we've decided to like provide a solution for people by producing a flight controller. It's called the Radix flight controller. It's a flight control system.
Sounds very smart.
And it's an F4 flight controller that stacks seamlessly and is fully integrated with both a power board or a 4-in-1 ESC, depending on what you're into. We are a company that, we want to make easy to use products that's well documented. We want to, we want things to be easy, but we also want to make the best flight experience for our customers. And we collaborate with our community.
So I don't know if you guys hear that. It's like our neighbors decided to vacuum. So.
That's fine. Let's just keep going.
Sorry. Yeah.
Wow. And so yeah, you want to talk about our product?
Oh yeah, so the Radix. I don't know, people are not familiar with it. So yeah, it's an F4 flight controller. So what's unique? The most unique feature about it is the OSD. Mm-hmm. So like there's these days a lot of flight controllers on the market with OSDs.
It's one of the most unique features.
I can't talk.
She's pushing you.
Anyways, so the OSD. So the OSD is different. So every other flight controller on the market basically has a, or let's say the Betaflight flight controllers, the racing flight controllers. Their OSD is text-based. So there's a chip that has been around for about 20 years. That is made to generate OSDs. The way it works.
4, 5, 6.
Exactly, it has been around since before FPV was a thing.
Yep.
Originally, it was very expensive, but these days, actually, I think the manufacturer Maxim that made the original chip doesn't make it anymore. So it's actually a Chinese clone product that's supposed to be better than the original at this point because they made a lot of revisions to it.
And the original was made 35 years ago.
Yeah, exactly. But so that chip basically can just put characters at different locations on the screen. And it's pretty basic. So our flight controller, so it's text-based.
And that's what every single flight controller is using today, other than ours. I'm going to let you talk.
Okay. So basically, our OSD, in contrast to that, it's a graphical OSD. So we actually use the F4. We basically use memory RAM in the F4 to draw the OSD graphically. So there's like in your computer. So we can have lines, we can have whatever we want, different size text in the same screen. So that's how it works. And then, there's custom circuitry to overlay that on top of the video. So that's how our flight controller works. And, it allows us to have some features like nicer artificial horizon, We have like a scale for the barometer.
Mm-hmm.
We have this thing. It's in Betaflight. It's a spectrum analyzer, so you can actually see the spectrum of your gyro. So instead of using black box, you can just look at that and adjust your filters if you want. What else do we have?
Our customers or anybody can just go to our website and download or upload a custom logo. And so we have two logos. So one is like the boot screen, so like when you boot up, and then the other one is like the pilot logo, and it's on the bottom. And so, you know, when you're racing, instead of just writing your name and the stupid, awesome Betaflight OSD, stupid but awesome, but yeah, you can actually put your own pilot logo, and so, you know, people, you know, it's just easier to post that raw footage with you know some
and that
having to edit.
Cool.
And so and people can also go on the website and you can make it public or private, your logos. And so you can vote on them as well. And so for all of our retailers, all of our dealers, we actually put their logo on the boot screen as just like a cool little like extra feature. So when somebody buys it from, let's say, Team Black Sheep, they, you know, the little sheep logo comes up when they boot up, which is kind of, you know, nobody else has that. So it's fun.
Yeah, it's a pretty neat feature.
Okay. Keep going.
So that's just the OSD.
Yeah, what else does it have? So
the gyro.
Well, it has we use a different gyro than every other flight controller. We use a Bosch gyro that runs at 3.2 kilohertz, and actually flies really, really well. And I think
but that's slow.
Yeah, that's the whole discussion is about, you know, how fast the gyro should run, and but it's interesting because, you know, for marketing reasons it makes sense to just push higher and higher numbers, but for actually flight performance it doesn't. So our pilots are very, very happy with our gyro, and a lot of people, you know, say it's the best flight controller they've ever had, even though they've flown 32 kilohertz before and now they fly only
3.2,
10 times slower.
Well,
but, you know, it works great.
Yeah, I do have a question about that, because another person that kind of agrees with you is, you know, KISS flight controllers. You know, they don't really push for big numbers, and it is widely regarded as some of the best flight controllers people fly with. So can you give us, like, I don't know, like the non-geeky version of why that is?
Explain it.
Well, of course, I don't really know exactly what KISS flight controller does, because, you know, it's not publicly known. But it's basically, I mean, you know, like your quad flies, right? And your gyro outputs a signal, or, you know, there's vibrations and blah, blah, blah. And
I have a whiteboard. We can pull it out.
No, I don't want to use the whiteboard. No, because...
Is that one of her toys?
No, I would have before I draw something. Not today.
Not today.
Not today.
Fine.
What I want to say. Yeah, so basically, you know, there's signal. So basically what you have is a signal, like the gyro signal, right? And and the gyro loop time, or loop frequency, I guess, like the 8K or 32K basically is like how fast, how often, how many times per second do you sample that signal, right? And in theory, there is like, you know, if you have a signal that's at 500 hertz maximum, you don't really have to sample. If you sample at 1,000 hertz or higher, you basically get all the information that's in that signal.
Right.
So there is some advantages of going maybe a few times higher. Maybe instead of 1,000 hertz, you would use 2,000 hertz or 4,000 hertz. And that's actually what it is about in a quad. Anything much higher than like 4,000 hertz or so doesn't make the signal much better. Like you basically get you don't increase the amount of information that you get from the signal.
Because you're still sampling at the same rate.
No, you're sampling faster, but the signal, if it's band limited, if the signal doesn't have information that's higher than 500 hertz, you don't really need to sample faster than that. So that's it's called the Nyquist sampling theorem, and it's very, you know, it's one of the fundamental things in signal processing. And of course, you know, there's some advantages of going faster, but like in our flight controller, we go 3.2 kilohertz. That's about 3 times faster than you really have to. And there are some advantages in reducing delay and so on. But, you know, then going to 32, in theory could give you some advantages, but there's basically diminishing returns. Like going from 8K or 3.2K to 32K, you can reduce the delay that you have in your flight control system by a few percent, like maybe 5 or 10%. So that's, in my opinion, it's not really worth it, because to do that, you also have to spend 10 times more computational resources to process your data. So I think it's better to actually run it at a slower rate and do more sophisticated processing on the data, because that allows you to actually get better flight performance. And I assume that's what KISS does too. Like
isn't that like why we use all the buffering and all the filters and all of that, right? Is because you actually you're sampling so fast that now you're picking up so much extra noise that you got to filter it off. Right?
Well, so one reason, yeah, to some degree. I mean, so in these gyros, like, so one reason to go to higher rates is like in the gyroscope. Like if you buy like a InvenSense gyroscope, right? You basically configure that gyroscope and you tell it how fast you want to use it. And there are filters that are inside, they're embedded in the gyroscope. And these filters add delay, and they're not necessarily. One problem is you don't really exactly know what these filters do, because the manufacturer doesn't tell you. So an advantage of going to higher sampling rate is that you basically disable these filters in the gyro, and then you have to do them in Betaflight or in Butterfly or whatever software you use has to still use filtering, because there is a lot of noise from the motors. Like on your quad is constantly vibrating.
Right.
Like the signal that you're actually interested in, like how your quad actually moves, is all below 100 hertz.
Right.
And above that, it's basically motor noise, and you want to get rid of it.
Well, yeah, exactly. The goal is to reduce that delay, right? I mean, that's the whole,
but you need filtering, and filtering always adds delay.
Definitely. Sorry.
So one of the things that you're really preaching here is that above a certain amount of hertz, really it's how you process the data that's going to ultimately give you a better flight performance or a better feel.
Right. And the more filters you add, the more, signal it's going to filter out. Right. I mean, and the more chances are that it actually filters out your signal and not the noise, right? Which is also a problem. So it can go in different directions, right? So filtering, adding too much of these crazy filters that people, enjoy using is also has its drawbacks. So you really want to be careful. And so basically what we're saying is that if you use a slower sampling rate with our gyro, you actually, and you can just use the default filters in Betaflight, the default settings, and it flies beautifully outside of the box. And actually somebody, Philipp Seidel, he's a German, he's from Germany, and he's a blogger, and he just sent us or I guess it was like a few weeks ago that he sent us a message that was like, oh my God, this is the best. This flies just as smooth as KISS. Like he is a KISS, Kiss or Die freak, fan. And he's like, oh my God, this is amazing. So, I mean, I think that, we're definitely on the same track as KISS. We really respect them as a company, and, we hope to one day, maybe this time next year, we can actually compete with them. So
hard brand to compete with, but definitely a worthy goal to do. So
right, it's a good goal.
It's a great goal.
So let me ask you something about filtering, because this is something that's kind of magic, right, for a lot of pilots, including myself. Is that like Betaflight? Every single time we turn around, they're implementing some sort of new filter or dynamic filter or whatever you want to call it. Like, what do these things actually do, and does it cause you problems? Because obviously it keeps constantly changing. That's one of the things that's almost a constant in our community, is that you're going to get new software and it's going to mess with you.
Yeah, I mean, so filter, right? What it is, right? You have a signal, and you basically
noise.
Let's say above, like, in the frequency spectrum, below 100 hertz is the signal I want, above 100 hertz is the signal I don't want, right? So the easiest way is to just what's called a low pass filter. Like that means like you have a cutoff frequency, and basically everything above is cut off or attenuated. Like, the cutoff is not perfect, so it has some fall off.
That's why we use it.
So originally that's what everybody was using, and that's actually what's inside the gyro itself. Like there's a low pass filter, which you kind of need. So when you like I had mentioned earlier with the sampling, no signal basically is perfectly band limit. If you the problem is if you sample too slow, then you can get what's called aliasing. So basically you get higher frequencies that kind of fold back and appear like lower frequencies, and you definitely don't want that. So you definitely want filtering to get rid of that. So the simplest is a low pass filter, and then at some point, what people realized is
aliasing.
Yeah. That's what it looked like.
Aliasing. We saw a video on, I think it was TBS, and so then we decided to draw it out. Anyways, all right.
So another option is a low pass filter adds quite a bit of delay depending on the order and so on, how steep it is. But so another option is if you kind of know, I know my motor nose is exactly at 150 hertz. You can use what's called a notch filter. And at some point, I think a year or two ago, that's what Betaflight added. It was these notch filters, right? So you can say I don't want this frequency from 120 hertz to 180 hertz. I want to get rid of that stuff. And that's what it does. It basically creates, that's why it's called a notch, right? It wipes out some frequencies. And then people were like, well, but tuning the notch filter is kind of hard. How about we adjust it all the time? So that's what the dynamic filter does. It basically analyzes your signal and looks above this, in the range where you know it's noise, like above 100 hertz or so. It looks at the spectrum. It looks at the frequency content of your signal and constantly adjusts the filter to remove that noise. So that's what the dynamic filtering does. And it actually works surprisingly well on quads. And then, now there's variations of filters like these bi-quad and blah, blah, blah. These are basically all low-pass filters that are slightly different in terms of delay and so on. So it's kind of, but yeah, I mean, in the end, for the normal person, it's pretty hard to understand or hard to understand. It's kind of, I just want to use something that works, personally, I want to build my quad, put it in flight controller, plug it in, configure it, go fly. I don't want to spend 2 weeks reading and watching YouTube videos of what best filter
how to tune your quad. I mean, we don't want to depend on the software filters, right? So we want to use the best hardware, so then you can use the minimal amount, or the default sensors, and because the whole goal is to reduce that delay, right? And so these software filters add the delay. So anyways, let's
okay,
what happened to auto-tune?
Don't start. Don't
what
start.
The hell happened?
It'll never work.
Patience.
Hold on, I want something that do that. Like you go spool the motor up, put them at half throttle, go put it down, put your finger on top of it, raise the throttle one time, drop it down. It knows I can go fly. That's what I want.
We'll be seeing a lot more of that in the future, I think. Within the next few years, I think that people will be implementing that into their software.
I've been waiting on that.
It'll happen.
It will happen. Whether or not the first implementation is any good or not, that's a different story.
well, I mean, you can use AutoTune with Dronin right now, which is a fork of Tau Labs, which was a fork of OpenPilot.
Yeah, it's been around. There are AutoTune implementations, and there was actually an AutoTune implementation, I think, in BaseFlight. There was extreme or clean flight. Yeah, it was very, very bad. Their AutoTune was very bad, and that's actually
it only worked for if you went over a certain period of time, then you didn't get a right reading, and it was messed up. So you could do it.
It was based on no theory. It was just kind of like hodgepodge put together. It didn't work. So that actually it's kind of interesting because that gave AutoTune a pretty bad name. In theory, you could actually do something, and I think the Dronin project has been working on that, and their stuff actually works significantly better than the original Clean Flight stuff did.
Okay, cool. One last question, and then we can get back to your product line. And that is the fact that as Betaflight gets more advanced, what we're noticing is a lot of people are moving up to to faster chipsets, right? Like, I'm still going to continue to use KISS as an example just because we've already done it, is that they're moving up to F7 boards. Now, are you noticing this trend as well, in which you're going to have to bump up in processing power because the software now is just taking up more processing time, and you just need to do that as a progression?
At the moment, we are still, like, we can still basically run all the features of Betaflight and not hit the limit. One reason is why it's because we are not running that fast. We are running at 3.2, whereas everybody else runs at least 8 kilohertz. But yeah, F7 is a nice chip because it's much newer than F4, and actually has some nice features, like, you know, the serial ports have inverters built in. F4 doesn't have that. So it adds some nice features like that. So we definitely at some point have an F7 board too.
Okay. Cool. Now, I think we've only talked about one of your flight controllers, and you actually produce other things like your 4-in-1 ESCs.
Yes.
Do you want to finish up on your flight controller, or do you want to move on to a different product? I've kind of lost track.
Yeah, so our flight, so actually we
We're
don't.
really
So our flight controller basically goes. So it's a Radix flight controller, and it can be paired. So it's the flight controller itself. It needs 5-volt to be powered. So you have to pair it with either a power board, distribution board, or a 4-in-1 ESC. And the way it works is we have a power distribution board that you can plug and play with the flight controller. So it comes with a little ribbon cable that connects the flight controller to the power distribution board. And the PDB is very nice. It supports up to 8S, 160 amp burst current measurement. It has LEDs on it, so you can bling your drone a bit. It has of course, like 5-volt regulators on it and stuff like that. You can connect telemetry to it for the ESCs and the signals and everything.
What's
so
that
it makes
big ass cap for?
Yeah, so it has an LC filter actually.
What's an LC filter?
So it's actually a low. So talking about filters,
right?
Your ESCs generate a lot of noise on the power line, and you don't really want that noise to come into your flight controller and video system. So what you need, of course, these noises at a certain frequency, so you need a filter to get rid of that. And the best way to do that, or one way to do that, is to use an LC filter. It's composed of a inductor, that's the L, and the capacitor, that's a tall component that's on the PDB. And together they basically form a low-pass filter, a physical low-pass filter, not in software.
What's the difference between a physical low-pass filter and a software, like a
this is actually electricals. It's an electrical voltage that you filter, right? It's an analog signal, whereas like inside Betaflight, everything is digital. So it's just the computer doing it filtering, whereas here it's actually like physical.
There's a chip or a cap. Chip.
Yeah.
So that or electrolytic.
So actually that provides very, very clean voltage to the flight controller, and also you can attach the video transmitters, and it's very good. It's much better than if you you have to attach a lot of caps. Like a lot of other flight controllers, you have to add like capacitors to clean up the voltage from the ESCs, which is kind of in one way silly because you don't really want that. Like it's not really necessary. It's actually you can actually make.
Somebody else says the same thing. I keep telling people, why are you guys putting all these damn caps on your system?
Because the video transmitters and the other PDBs and so on the market don't properly filter the signals.
No, I'll say this, Martin, is that like a lot of the stuff. Okay, so like we were talking about earlier, a lot of people don't understand how to actually solder, and I'm not talking bad about them. I'm just making a statement about people. A lot of people that claim they know about RC or they've been doing soldering, I've been soldering for the last 10 years, really don't know what the hell they're doing, because like someone that went to school, okay, so like real quick, I'll say this. If you solder and you solder the tip of the wire, and when you go to grab the tip of the wire and you go like this, if it has restriction, that means you heated the wire up too long and the solder wicked further back into the wire. That means you're not using the proper heat, the proper flux, and the proper soldering iron. I'm sorry, but that's just the rule.
That's true.
All right. So back to
where-
caps. Back to caps.
Yeah, so basically an LC filter is like you don't really have, like, if you think about it, right? Like, you don't really have to clean up the power on your whole power system. You just want clean power for your flight control and your video stuff. So that's the power you have to clean up. So you can actually make it much, instead of having huge capacitors that you attach to your battery pads to clean up everything, you can just have an LC filter that's much smaller. It can only provide a few amps because the inductor has a limited amount of current it can support. But physically, it's much smaller than the big caps and provides better filtering. So it's a better solution than having big caps that you have to attach to your flight control or the PDB. So anyway, so we have this PDB that stacks with the Radix, and then we actually don't have our own 4-in-1 ESC. So we made it so it can be stacked with the Hobby Wing 4-in-1 ESC.
Ah, okay.
Because
That's a good one. That's a good one.
Yeah, so we try to figure out what's the best ESC on the market, and a year ago or so, and that a year ago it was pretty new, and it's still one of the best ESCs on the market. And I think they're coming out with a new one, and of course we will have a different cable that connects to the new ESC once they come out.
Well, I can contest that. That's the one that everybody tells me that doesn't blow up.
Yeah,
That's always good. Now, let me ask you this question. You talked about having that LC filter to be able to clean up the power. That's excellent. Is there an advantage, though, to adding a caps to, like during like hard punch outs in which that cap actually provides a benefit in terms of what it's supposed to do, which is add capacity?
So in punch, actually, not really. So the capacitor, if you actually calculated the amount of energy it stores, is maybe enough to power your motors for like 0.01 seconds, like 100 milliseconds, like not even 100 milliseconds, 10 milliseconds.
Even
so
at
it doesn't really give
microfarad. Even at 4,000 microfarad.
You actually can calculate it, right? Like 1 farad. So like capacity is measured in farads, right? So if you had 1 farad and you draw 1 amp, it lasts for 1 second.
Right.
Basically. So if you have these capacitors are maybe 1,000 microfarads, so 1 millifarads. So if you draw 1 amp, it will be empty in 1 millisecond.
Right.
But you're drawing like 20 amps, so it's like 20th of a millisecond, right? 100 amps, right? So it's really like the time scale is like way off. Like you would need a capacitor that's huge.
Yeah, you would need one this big.
Yeah, exactly.
This big, seriously, this big to hold your quad.
Yeah, capacitor is very, very bad. Yeah. The energy density they store is very bad compared to LiPos. But they can do it very fast. They can provide a lot of current very, very much faster than a LiPo can. But so you do need capacity. So if you look at the ESCs, there is a lot of chip capacitors on there, ceramic capacitors. They're usually the brown parts, and they are necessary to provide power when the ESC is switching, or when it's breaking. They have to kind of store some energy when it's breaking to even out the voltage. And there are actually, I think, some bad ESCs on the market. They can actually basically the switches, like the FETs that are on the ESC, they are rated to a certain voltage, and if the capacity is basically not big enough and you have breaking, the voltage can exceed what these are rated for, and you can actually destroy your ESC. But a properly designed ESC shouldn't have to attach additional capacitors to save your ESC. You know what I mean? Like the ESC should be designed to work without additional capacitors.
Yeah, back in the day, you only needed 290 microfarad to clean up a 12-volt ESC.
Yeah,
that's all you needed. You didn't need more than that.
Yeah, I mean, one problem is with the high, these days we run like 5S or 6S, and these chip capacitors that are on the ESC, their capacity is very, very low. Like, even though they may be rated for 10 microfarads, the actual capacity is voltage dependent. So if it's a 30-volt capacitors and you use it at 25 volts, it maybe only has 10% of the capacitor capacity that the manufacturer says. So it's much smaller. Like ESCs that actually uses like an electrolytic, like the can-shaped capacitors, are usually much better suited, but they're not as small. So, and so it's kind of a, for airplane ESCs, you still see a lot of the old school capacitors that we also use for the LC field.
Okay, cool. That's actually a lot of knowledge right there, and I appreciate the help.
I almost feel like I'm in class.
Exactly.
So, long story short, yeah, like you want to trust people who know what they're doing. The people who know what they're doing. And so like buy our electronics, because we actually do know what we're doing. Sorry.
PhDs.
That was
there you go.
We try.
No, but seriously, I think that a lot of so I mean we're competing with a lot of people, a lot of companies who are making maybe I don't know.
Don't get yourself in trouble. Okay, I'll move on before she gets in trouble.
Suboptimal electronics for your drone, which in turn, no, but it's true. So like it may be cheaper, but in the end, it's more expensive, right? Because you're crashing, and so then you have to buy a new part because your flight controller, whatever sucks, and then you have to get an entirely new frame and new props and a new power board and new ESCs and all of that, and that it's expensive. So in the end, if you invest in the thing that actually powers your that controls your drone, the flight control system, it's worth it, and I think that people are realizing that more and more, that there is a demand for like the high quality products, so and innovation.
No, I will say that a lot of people that truly fly a lot, once they find a product that they like, they very rarely switch until they absolutely need to. Like a couple of the pro pilots, I mean, they'll be like, once I fly a flight controller, I'm going to order 15, and that's good for the year. It's like, that
true.
makes a lot of sense. So,
for sure.
Okay, Elvin, I'm going to leave this part up to you. I hear you guys are creating a flight controller for a wing. So I think that makes Elvin very happy, right?
Yeah, it does. The reason why is because there's a couple of companies out right now making wing flight controllers, and I think they're going in the wrong direction.
Oh, tell us why. In what way?
Okay, so like
I'm taking notes.
I think a lot of the things that is going on is so with a wing, you don't need the same horsepower as you do on a quad, right? You have a lot less things to actuate and stimulate and take data from. So that's one thing. So I want to see more innovation in the thought of the first pilot, right? The first pilot, he has a problem with doing what? Launching his plane, right? He has a problem with setting up his plane. The iNav setup, it works, and it works well, but it still can be complicated for a new pilot, especially since, as you said earlier, the problem with a lot of the newer flight controllers is they're not documented, and neither is iNav, right? The problem with when you change software so frequently is you don't give documentation time to catch up with the product, right? So when you do that, you got a guy like me who last week I was flying just fine, and then this week, now I got to go learn something else that you decide to change. And I think we need to stick to a basis on what we're going to do for a beginner pilot. So you may have all these other options, like, this gyro, that gyro, this, GPS, this, data sensor or whatever, sonar sensor and temperature sensor and all of this. I don't think all of that is necessary. I think give a pilot an opportunity to start off with something basic.
Yeah, I 100% agree.
Flight controller, GPS. Those two things, right? Because you can get a lot of data off of those two things. You can get I mean, the right GPS can tell you your altitude, can tell you with a borrow, can give you your altitude, your location, your 3D location on the planet, and how fast you're moving, and be able to compare your airspeed against your ground speed, because that's one of the things. That's why we have so many. We have the GLONASS GPS system, which kind of works like a compass and a GPS because of the data. So I think that's one of the problems is with this the wing flight controllers is they're giving guys all these things, and everybody's like, oh, let me get this working, oh, let me get that working, let me get that, and they've spent too much time trying to get stuff to work and not enough time out flying, because the flying part is what's going to give you the most amount of experience and ensure the fact that you won't be having bad effects.
Yeah.
I think the problem, I think in all of the industries, right, is like people think that something that is easy to use is only for beginners, right, and should be cheap. And, and I think that we're trying to kind of challenge the way people think about building and flying drones, in the way that, like, we want to make a superior product that's both for, for beginners, easy to set up, easy to use, but also for advanced flyers where they can add, more advanced, and just lower that barrier of entry. Sorry.
But so coming back to our new product, right? So it's actually not its own flight controller. We basically making it's called the WPV, the wing power board. So in addition, it's an additional product that so you can stack the Radix flight controller onto the Radix wing power board, and then you connect the servos to the wing power board. It has a 3 amp back on it, which is enough for very small servos. For bigger servos, there's like a jumper, so you can power it from the ESC to servos. And so it makes using it on a wing easier. And then we have an iNav port where we basically do the same as in Betaflight. We have, a nicer OSD with additional graphical features, so it looks more similar to like a better flight controller in terms of like we have like a map mode and stuff like that in the OSD. So it makes flying nicer with a full OSD. But in the long term, we definitely it's in that direction we want to go. Is we want to make something that like a completely it's like a project. It's probably at least a year out, and we want to make hopefully less, but it's a lot of work. Like make a whole new generation of flight controller that doesn't use iNav, doesn't use Betaflight, we use our own software, and
has like a wizard for a configurator, right?
The goal is
you kind of put in your settings, and it kind of it learns based on all of the other data that it has to help you with your tuning and your setup in general. Which, like again, like you said, it just makes it easier for the person who's building their.
But the goal is to make something that is extremely easy. It's a very difficult thing to do, but I think it's possible. Like make a product that's so easy to use when you first start, but then you can grow with the product. You can start by just putting in your airplane, plug in your servos, do some calibration, like it walks you through it, and you go fly and you have fun. And then if you want, you can go all the way to do like mapping with it.
Right.
Like I think that's how it should be. Like you basically you don't have to know everything when you start, but it should be easy to start, right?
Exactly, and then you can add on.
I think
you wanted to.
It's like my okay, so like I just put iNav in one of my wings, and I was having problems with the system. It kept doing weird stuff, so I ended up taking it out. And it's not really iNav's fault. It's probably the flight controller. I mean, something it was working just fine once before, and then I took it out, put it back in, and then all of a sudden it developed an issue. So it's more than likely the system, not the flight controller. But the thing is that it happened, and because I know what iNav has done for me in other situations, I can say, okay, that's not me. That's something wrong with the flight controller. That's something that's the system. So that's not me. And I can fly the ship with it or without it. But with other people, that's not there, So they don't have an idea of, I don't understand why that's doing that. I don't know, why is the ship doing that when it's supposed to be doing something else? And no one really can tell you because you don't really know how to explain it, right? And that's a big issue. So I'm thinking that the wing thing is launching is the hardest part. Then flying is the second hardest part. And then landing is the third, right? So, like I hit myself in the arm the other day because I was trying to land in between me and a buddy of mine, and I clipped my arm on the way in, It was pretty funny.
Martin has a really funny story.
So stuff happens. Go ahead.
In your launching story, he knocked off like the entire the GoPro on his Kaipi when he was testing the wing power board, so he wasn't even able to fly.
It happens.
Martin
Everybody crashes. If you never fly, you never
He's like,
crash.
Jenny, stop.
If you never fly, you never crash.
Martin did not want that story to get out.
He did not. He was like, please don't. And I was like, yeah, that's happening.
Right.
If you asked me for it, I'm gonna say it.
You two are funny.
If we ever go flying together, I got some stuff like you gonna laugh because like usually I get 2 or 3 throws that'll go perfect, and then that fourth one is garbage. Because my arm, by the time I end up throwing that big 60-incher 4 times, it's like I just tossed 7 pounds in the air. You know what I mean?
Yeah.
Oh God! And that 4th time, that arm is like. Eh.
I will say though, okay, just getting a little bit back on track. Like the next generation of boards, like definitely supporting the open source software is great, but there are some really good benefits of going closed source, building your own flight control operating system, and like if you incorporate some best practices in the open source world into your closed system, I think that would be awesome. Like having more than one preset, because like not everybody builds a drone the same way. Not everybody knows how to properly balance a quad. And this is one of the things that I've always kind of interested me, right? Is that we know that you're supposed to balance your quad so that when you pick it up in the center, it's supposed to balance perfectly. It's funny that we've never actually built something into the OSD that the moment you lift off, the quad should tell you, you did not balance this right because the proportion of my motor lift is terrible. Okay,
I'm getting a pen so I can write this down. This is genius. 1 sec.
I mean, I'm not trying to make it like mean, but like that would help so many people with a better flight if you just sit down and say in your OSD says, you need to land and you need to move the battery because it sucks. Okay? And I'm serious. Like a lot of pilots can feel that difference, 10-20% difference in your center of gravity. You'll know it in the air. So to have something that just tells you that, that's a great innovation in itself. So, okay.
I would like to see a quad with something that makes you have to tune it.
Man, you just made me get in trouble.
This is day 4 that you haven't tuned your quad. The quad is shutting down.
I would not fly more.
I would never be able to fly, Elvin. Come on.
God,
that's terrible.
So amazing. It's like in the Fitbits that people wear. It's like you have walked only 4 steps today. Right. Like you fat ass. Oh, sorry.
So
we should totally make something like that.
So not to be too mean-spirited about that, but I think there is a lot of innovation to be said between what me and Elvin have discussed, in which the quad, either before it's flying or after it's flying or during it's flying, it should give you feedback on like, listen, you need to actually like tune your P or tune your O because like I should not be wiggling like this in the air, or something like that. It should be possible.
It'd be nice, yeah.
I would think that's.
I think that with that we have to
It's not easy.
Yeah. I mean, I think that there's a lot of work to be done, and a lot of data to be collected, because that's almost like a machine learning, like predictive model type of thing, where like we would just need a lot of data for that. And I think that it's possible, and it's something that I've thought about implementing at some point. So
I'm sure you got a
One day.
machine over there that'll fit to my.
So what I just heard is that your next flight controller can support 128 gigabyte SD card.
Oh, easy.
Probably.
I mean, like we'll have three of them. It'll have has a pony. It'll make coffee for you. Espresso.
Espresso. Ooh, I like this. Anyways, I'm actually really glad that you two are on. I've actually learned a lot about flight controllers, and there's a lot of myths that you kind of already busted in terms of like clock and also filtering, because these are really popular trends right now in FPV. And a lot of people just go with the trend and not really know why they're doing it. That includes me, by the way. So because I don't have time to go look this.
I think that a lot of people, that I've talked to, they're just super excited about, something that's new and different, and like, the whole hype train thing. And I think that like in general, our company, we've been around for a long time, and not a lot of people know about us, but I think that we've proven that we're pretty stable, and I think stable beats the hype, in the end. And I don't know, I've never been interested in entering, that higher, whatever, getting on that hype train. We just want to make, and develop it and innovate and, iterate and collaborate and just like keep pushing it. So
if you can incorporate machine learning, I'm sure Microsoft will buy you out eventually. That's all I'm saying.
Sweet.
That's the goal.
That's what I specialize in. So
well, they're right up the road. They're right up the road.
Then we can make something better.
I can take you up there and walk you around.
Oh dear, yeah, that's actually true. But you can talk to Elvin about that. So besides the flight controllers, is there any other projects that you're working on?
Not really.
So, we have the wing power board that's coming out soon. We have a not that I can talk about.
Color.
Okay.
Colored.
We try to focus.
Wait. You got your flight controller. You got the wing PDB. You got the Radix PDB that goes with for the quad, and then you have there was something else. You got the little light, the light thing. What is that? I'm trying to get to the
light thing.
There's a light thing.
We put LEDs.
You mean the
yes.
The PDB
LEDs.
has LEDs on it.
Yeah. So that has LEDs.
That's
in
the PDB actually.
it.
The PDB has 4 LEDs.
Are you thinking about the add-on of our previous product? Is the Barrow, that little red thing? That was the barometer, but we've integrated the barometer into the Radix, into our this current flight controller, so you don't even have to add on anything. It's already in there, so you know how high you are. And that's another thing that's integrated into the OSD, so you have that little like ladder that shows you altitude.
I mean,
nice.
We are at the moment we are focusing solely on flight controllers or very closely related parts.
Because that's what we're good at.
Yeah, that's what we're good at, and we have limited resources and limited amount of time. So instead, we could try to make every part. Like a lot of companies go and they make a flight controller, and they make a video transmitter, and then they make a 4-in-1 ESC, and but none of them is the best on the market.
Right.
So what we want to have is we focus on what we are good at. Like these flight controllers at the moment, and we make that. In the future, if we grow and if we have additional people, we may make a video transmitter too. But we are not experts in making video transmitters, so it would be hard.
Like falling in that trap, I feel like
it's hard to make the best on the market if you're not.
We're smart enough to know what we're not good at.
Well, Don't fall for the hype of everybody. Y'all have to make everything everybody else makes. Don't do that, please.
No.
Please work on it. Stick with what you're good at. Stay there, because I think, like you said, your thought process is you're making flight controllers based on science, right? So that's where you need to stay.
But it's based on science, but it's also in, partnership and collaboration with all of our pilots, and we're pilots too. And so it's, and we put them in hands of everybody from beginners to advanced. We have Maddie Stuntz, who just, messaged me right now while we're talking, and, and everybody in between. And so, and this market is so fast changing and it's constantly evolving. And so we have to keep up with that evolution as well. And so we want to be at the forefront of that evolution, and we want to be the ones pushing that envelope to into the future, and just completely challenging and doing things a little bit differently. And so
I totally agree. And if you do develop your own software in any way, or okay, later. Anyways, let's go.
I want to hear what.
Well, let's go ahead and move on, because we're over an hour. I told you we wouldn't have.
Sorry. I know.
I told you we wouldn't have a problem filling an hour. Let's go ahead and talk about the Jamboree, which is something that you're going to be the title sponsor on, because we love FPV events, so we definitely want to fit that in. Tell us about the Jamboree.
Okay. So it's this awesome 3-day event, and it is at the end of July 27th through 29th. And it's in Oregon, which, if you're not familiar with the state, it is a magical state, right, Elvin?
I like that.
It's up in the great God's country.
It is. It's beautiful. So we have a friend, one of our customers, who puts on this event. This is the 3rd year, so it's an annual event. And this year it's invitation only, but you can sign up for an invitation on the website, and cost is free for all the pilots. And so it's more of a party, but it's also for families and spectators. And so it's not just, completely FPV centric. There's door prizes from, he has a 3D printer, and we have community art projects for kids, and there may be a hot air balloon, and
there's going to be a band.
DJ. And they have, just all sorts of things. Oh, a river rafting trip one day. And they have.
I think they did that last year too, right?
Yeah, exactly. So, and then on the very last day, they have what's called a death race, and it's insane. It's like this crazy obstacle course, and it'll take you several packs to get through. And basically, the person who can actually get through it will win. It's not even a race. It's literally can you actually get through it? And he has fire.
And water.
And he has water, and
there's
he has
a saw.
There's a hacksaw, and he has it's insane. And so
don't use your newest quote.
And so yeah.
I'll make sure to use my brain FPV.
So Matt, he's the one who's organizing this, and he's putting. So he has years and years of experience in planning events, and he's just all over it. And so he's putting the cost for the pilots. So all you have to do is get here, and it's going to be just really cool, really mellow. It's not a race where you can add, whatever. It's not like you win this and you have multi-GP points or whatever.
Yeah.
It's really
it's a
just
freestyle
for fun.
competition.
It's a freestyle.
I think that
actually
the freestyle competition is somewhat competitive.
But every person who's
pilots.
been says that they've flown more packs than any other event they've ever been to. And that's pretty cool. There's camping. Yeah, so you can bring your family, you can bring, friends. I mean, obviously, we want to keep it somewhat small, but if you're interested,
they keep it pretty small.
Yeah, check out the website at fpvjamboree.com. My dog is he's excited.
The dog wants to go.
He's going.
Yeah, and so we're going to be giving away lots of, prizes. You may win. And so actually, if you sign up, you get all sorts of, depending on when you sign up and everything, you get tickets. And so all of your tickets will go raffle tickets. And so all of your raffle tickets will go towards all different prizes. And so you can win a BrainFPV flight control system. You can win a hat. You can win a 3D printer. You can win, oh my gosh, he just, yeah,
well,
there's
a ton of
sponsors.
And...
There's, yeah. I mean, we just released it. So, yeah, we're just waiting for people to sign up, and I'm sure we're going to get a million more sponsors. But right now, TBS, twin quad frames, race day quad.
What else? For a flight.
Forward Fly. Yeah. Anyways, there's a pretty hefty list of sponsors right now. So
Yeah.
So there you go. If you're in the Oregon area, it's going on July 27th, going all the way through the 29th. Definitely put in your application and go out and have some fun, because that's what FPV is all about, which is, go out, hang out with the community, and get a chance to win some really cool prizes. And you can also go bug the BrainFPV guys and gals about the stuff that you want in your flight controller.
Definitely. Please. We depend on your feedback, so please. We want to hear what you want.
Elvin, what do you want in your flight controller? And then we're going to start wrapping up.
I
He's
want it
good.
to work.
You want it to fly for you.
No, I don't. I'm not one of those guys.
He wants a manual mode.
He wants.
I love manual mode. I love manual mode. I can tell when
zero latency.
Okay, so I flipped out. Like, okay, so like I was flying my mini drag, and I was flying above the trees, dipping in between the trees, right?
Oh,
and I was like, every time I would dip down in the trees, it took like a half second more for it to respond to come back up. And I was like, what the hell is that, right? So everybody's like, oh, just put it in pass-through mode. I'm like, it's in pass-through mode. I can feel it. No, you can't feel nothing. Don't tell me what I can feel. I know what I feel. And the guys are like, no. And then as soon as it came back from another pilot that's like got a big name, everybody was like, oh yeah, I can feel it too. I can feel it. And I was like, yeah, whatever.
Oh my God. That is this industry in a nutshell.
Right.
So you've just
it's
beautifully put.
Yeah.
You just wrapped it up.
Anyway, if you guys are interested, we live in Portland together, and I fly several times a week, Monday through Friday, and on the weekends. And like I told you before, tomorrow I leave in the morning to
Bend.
to close to Bend.
We're so jealous.
We're going to be flying wings, Drax, and Anubises, and all kind. And one of the guys has got a Cappy too, so hopefully I get to see it fly.
We have a Cappy.
And if Justin, you fly too slow in front of me, I'm gonna run that son of a bitch over.
What did I tell you about cussing? What did I tell you?
For the listeners, so he's going to this incredible spot in the most beautiful part of, or one of the most beautiful parts in Oregon, and he sent pictures, and it was just like Martin and I, we were like drooling. We're like, oh my God.
I told my wife, I said, we're going camping there.
Yeah.
Twice this year.
We'll go with you.
Yeah.
We'll join you.
Next time we're gonna. I want to do that. So like that's one of the things I've been wanting to do too with wing racing is do a big coast race where we go down the coast and maybe we're racing a half mile up and down the coast.
I'm in.
We'll
sponsor it.
Not just half a mile that way, but I'm talking about half mile that way, and then a couple of turns and twists in between that. And I want to do that. And then one of the things too is I wanted to initiate Oregon style wing racing, because we have the trees, right? Nobody else really has all of these beautiful trees, to duck and dive into.
You gotta
sideways. And like
it's
I
like
said,
Star Wars.
Yeah, and like when you really get moving, like I said, I can turn my mini drag on its side and hold it vertical for a second and a half.
Wow.
If you don't think that's a long time, that's a long ass time.
Yes.
Yeah, there's a lot of beautiful areas you could do with races here.
Oh, Oregon style. That should be like a thing, like Oregon style wing racing.
Trees,
there you go.
Dipping and dodging.
Maybe up in the ski areas, in the summer.
I've said that in Meadows. We'll talk later.
Yeah, let's talk about it next year.
All
I
right,
just
yeah.
need a little bit of backing.
This was a good collaboration.
There you go. All right, let's go ahead and start wrapping it up because we are getting to that time. Just one thing I just want to say is that I hope you guys are working on a micro flight controllers because little mini ones, they're so cute and everybody loves flying them. I'm just saying. One day, there you go, that little guy.
That's a story from another time. Because we have a story for that too.
Okay, sounds good. So as we wrap up, any listeners who are interested, definitely go over to brainfpv.com, check out their flight controllers, and they're definitely going to be around, and they definitely know their stuff if you've listened to this podcast. So as we wrap up, if people want to reach out to you, where is the best social media site that they should go to?
I think probably our user group. So on Facebook, we have a group. So if you go to Facebook/groups/BrainFPV, that is where we're most active. Also, if you just email us at support or info@brainfpv.com, we're really, so yeah, we pride ourselves on our customer service and we get back to everybody within, at least a day. Yeah. If not, almost immediately. We're pretty neurotic about that. So yeah. And we want to hear from you. So please reach out and say hi.
Okay, cool. Besides brainfpv.com, is there any other websites that your products are offered?
A lot, yeah.
Everywhere.
So we have US retailers. We have Get FPV, Ready Made, Race Day Quad, Pirate Drone. Who else?
I'm going on our website. If you go on our website and go on retailers.
We have international retailers, a few in Europe. We have Team Black Sheep is selling it. There's another Hong Kong retailer.
So there you go, folks. You can pretty much get it anywhere.
It's on our website. We have 2 in Asia, about 5 in Europe, and about 7 or 8, about 10 in the US.
Legit, Get FPV, yeah. So, yeah, we have a bunch of stores and we have a bunch of pilots as well.
Yeah, we just.
Can we shout out? Can we shout out to people?
Yes.
Okay, shout out. So to Gab707, to Just by Chance, to Kev FPV, to Maddie Stunts, to Nicholas49, Quest FPV, Rotor FPV, Salty Dave, Skyberries, and we just signed Code Red today. Yeah. So yay.
So now
we have 10.
10 sponsors.
Our family's growing, guys.
Our family is growing.
These guys are like everything to me, and so I just want to shout out and say thanks to them because we wouldn't be there. We wouldn't be here without them, and we wouldn't be here without you guys either. So thank you for supporting us and having us on your podcast. It's awesome. We're super stoked.
Yeah, I learned a lot, and I would say that anybody who's a KISS flight controller fan who don't want to pay for the premium price, you might want to check out their flight controllers. Seems like their philosophy is similar to what they're doing over there. And let's just face it, KISS stuff is always going to be expensive. So if you want to go to the open source side, good flight controller to check out.
Yeah, thanks.
All right.
And they know what they're doing. So that's awesome.
All right.
They're smart. They're not just silly nerds, they fly.
PhDs in brain science. That's all I'm going to say. Okay, I expect the first AI OS flight controller out in like 6 months, okay?
Cool.
You're on the time.
Okay. You'll test it for us?
Oh, dear.
No. Why is it a computer?
As long as it flies into Elvin's head, it's a pass. It's a pass. Okay? That's all I'm saying. Okay. We are out for the week. Thank you so much.